Okay, now we move to the liquid-liquid extraction. In order to separate or remove one or more of the components in the mixture is brought into contact with another phase. The mixture can be in any two-phase pair, for example, between gas and liquid, vapor and liquid, liquid and liquid, and between the fluid and solid. Firstly, we focus on the separation between liquid and liquid, also known as the liquid-liquid extraction. Liquid-liquid extraction is a process where a solute in a liquid solution is removed by contacting with another liquid solvent that is relatively immiscible with the solution. Liquid-liquid extraction, also known as the liquid extraction and solvent extraction, is a process where the two phases are chemically quite different, which leads to a separation of the components according to the physical and chemical properties. Okay, liquid-liquid extraction, also known as a solvent extraction, is a method to separate compounds or metal complex based on their relative solubilities in two different immiscible liquids. For example, between the polar and non-polar, okay, normally water and organic solvent, okay, which is water is a polar uh, chemicals and the organic solvent is a non-polar solution. Okay, there is a net transfer of one or more species from one liquid into another liquid phase, generally from aqueous to organic. Okay, the transfer is driven by the chemical properties. Okay, for example, once the transfer between the solute, okay, from the mixture, okay, to the organic solvent, okay, which is the non-polar liquid, is complete, the overall system of the chemical components that makes up the solute and the solvents are in a more stable configuration, which has lower free energy. Then the solvent that is enriched with the solute is called as extract layer. Okay, while the feed solution that is depleted in the solute is called as the raffinate. Okay, this liquid-liquid extraction, okay, can be used as an alternative to the separation by distillation or evaporation, and is a basic technique in chemical laboratories where it is performed using a variety of apparatus that we will learn by next semester. Okay, from separatory funnel, okay, in order to counter current distribution of equipment that called as a mixer settler. Okay, this type of the process is commonly performed after a chemical reaction as a part of the workup, often including an acidic workup. Okay, liquid-liquid extraction can be applied in various industries. Okay, for example, acetic acid can be removed from water, okay, by distillation or by solvent extraction using organic solvent. Okay, the resulting organic solvent acetic acid solution is the distill. Okay, meaning that from the mixture of acetic acid and water, this solvent, organic solvent, okay, has high intensity, okay, to the acetic acid only, and the resulting organic solvent and acetic acid from this process, whereas we call liquid extraction process or the solvent extraction process, will come out as a stable configuration mixture which has a lower free energy, okay, from the extractor as a called as a extract layer. The liquid-liquid extraction is a process where multi-component liquid being separated using extraction technique by utilizing solvent. The schematic diagram of the liquid-liquid extraction is presented here. The multi-component liquid that consists of component A and component B is built up by the solute, which is the component A, and B is act as a dilute. Normally, the mixture of component A and B, which is between solute and the diluent, is contains as a aqueous solution, and this aqueous solution will be attracted, okay, will be engaged or will be contact to component C, which is solvent. Alright, okay, there is a net transfer of one or more species from one component into another component, which is from solute, okay, in aqueous solution to the solvent, which is organic solvent. And this transfer is driven by the chemical potential. Okay, for example, once the transfer is complete, the overall system of the chemical components that makes up the solute and the solvents are in a more stable configuration, which is has a lower free energy. And the solvent that is enriched with a solute, okay, is called as an extract layer. You can see here, extract layer has the products of A, okay, and C, whereas the solvent that enriched with the solute. However, the feed solution that is depleted in the solute is called as raffinate layer. Alright, and you can see from this liquid-liquid extraction, the raffinate layer consists of the product A and B, okay, where the percentage of A is reduced as compared to the feeding stream. Since there is no involvement of heat, there is no energy balance considered, and left this process to be involving only material balance. For example, the separation between water and chloroform by using acetone as a solvent. Acetone is consists of carbon, hydrogen, and oxygen. Acetone has the chemical potential towards only either one from these two solution, okay, or aqueous solution. For another example, okay, the high molecule of weight fatty acid can be separated from the vegetables oil by extraction with liquid propane or by high vacuum distillation. Okay, liquid propane is a chemical that has the chemical formula of C3H8, okay, which is the chemical that composed of the elements C and H. This propane solvent will attract the fatty acid, okay, from vegetable oil and develop or we call build up an extract layer, while the remaining fatty acid inside the vegetable oil will leave the liquid-liquid extractor as a raffinate layer. Alright, so instead of using liquid-liquid extraction to separate the fatty acid from vegetable oil, okay, this process can be also separated by using the vacuum distillation. However, the application of vacuum distillation involved with very high cost. The second example is metal separation are being done commercially by extraction of aqueous solution such as copper ion, uranium vanadium, and tantalum columbium. Okay, and this mixture of the metal, okay, are in the form of the aqueous solution, and the selection of the solvent to attract, okay, via chemical potential to any of these metal depend to the desired or to the request from the supplier. Alright, besides of liquid extraction, we are going to learn about the separation of liquid solid extraction that commercially known as the leaching process. Many inorganic and organic substances occur in a mixture of different components in a solid. In order to separate the desired solute constituent or remove an undesirable solute component from solid phase, this solid phase is contacted with a liquid phase that is normally known as the solvent. The two phases are in intimate contact. The solutes that originally in the solid can diffuse from the solid to the liquid phase that normally known as a solvent, resulting in a separation of the component. And this process known as the liquid solid leaching or simply leaching process. However, in leaching, when an undesirable component is being removed from solid with water, this process is called as a washing process. For example, leaching of sugar from sugar beets with hot water. This sugar beet has intimate contact with liquid hot water. Then, the solute that consists of sugar will diffuse slowly from this sugar beet and diffuse to the hot water to form the sugar solution. The second example is the extraction of oil from either peanuts, soybeans, sunflower seeds, and cotton seeds by using organic solvent such as hexane, acetone, and ether. The second example is normally be applied in vegetable oil production industry. According to this example, the oil will be slowly diffused, okay, to the solvent. The solvent can be in either hexane, acetone, and ether, which are the chemical molecules that build up from the elements of C, H, and O. And this oil, okay, will be separated from the originally solid, okay, which is the seed, to immerse or to diffuse slowly to the solvent. Okay, the third example is the leaching of tea leaf by water to produce soluble tea and to remove the metals as soluble salts. This leaching of tea leaf by water is normally be implemented in our daily life. The schematic diagram of the liquid-solid extraction, or known as the liquid process, is shown here, where the raw material is presented either in the form of solid or fluid. Okay, from this mixture, only one component based on this diagram, A, is act as a solute. As a terminology, solvent C will extract solute A from the slurry B, meaning that solvent C must have high chemical potential to the solute A. Then, the solvent C that enriched with the solute A will come out from the leaching extractor or the liquid solid extractor to form the extract layer that consists of component A and component C. Okay, then some of the solute left with solid B will be removing out from the liquid solid extractor as a raffinate layer. This process involving material balance, okay, there is no energy balance is being considered because there is no temperature difference is played around. There are few examples that according to different types of application. Okay, for example, in industry, they use a leaching of sugar from sugar beet in order to separate, to extract the sugar from sugar beet by using solvent. Okay, however, in daily life, we use leaching as a simple process in order to make a hot tea. Then the lab scale application is the leaching of salt. Okay, now let's move to the absorption process by using scrubber. Absorption process is a process where a component is removed from a gas stream by treatment with a liquid. Absorption, in other words, can be defined as a process of mass transfer process in which a vapor solute A in a gas mixture is absorbed by means of a liquid in which the solute is more or less soluble. The gas mixture consists of an inert gas and solute. The liquid primarily immiscible in the gas phase. Vaporization of liquid into the gas phase is relatively slight. And this process is only involved with the material balance. The schematic diagram of the absorption process by using scrubber is presented here. As a terminology, the solute A from the raw gas B is being absorbed from gas phase B by using the liquid solvent C. The liquid solvent C must has chemical potential to the solute of A in order to able to separate A from the gas phase of B. However, this liquid solvent C cannot be miscible to the gas phase, and then the vaporization potential into the gas phase is also relatively slight. The liquid solvent C that enriched to the solute of A is called as an extract. Okay, that consists of the components of A and component of C. Okay, you can see here the solute A is recovered from the solution, okay, by using the distillation mechanism. Okay, for example of the absorption process, the separation between CO2, okay, from natural gas by using amine. Okay, so for the example, okay, solute A is consists of the CO2. Okay. P is natural gas. In order to separate CO2 from natural gas, liquid solvent must has high affinity or high chemical potential to CO2. In industry, the common liquid used to separate CO2 is known as amine, because amine consists of the nitrogen that has the dotted pole here in order to attract C, okay, by using the covalent bond. Then the liquid solvent that enriched with the solute A is being absorbed in order to remove from the scrubber. And then the raffinate product that consists of the solute that has low affinity to liquid solvent C is still remain in the natural gas B and will remove as a raffinate layer or raffinate product. Second, the separation of CO3, which is the sulfur trioxide, from air into water. Okay, water here has only attraction towards CO2, okay, because water is known as the polar, okay, of hydroxide and also hydrogen plus, and this when has a contact to the SO3, okay, from air, it will attract by using the chemical potential to form, okay, to form a product liquid of A and C, which is between solute A and the liquid solvent C. The inverse of absorption process is known as stripping process. Stripping process is a physical separation process where one or more components are removed from a liquid stream by a vapor stream. In industrial application, the liquid and vapor streams can have co-current or counter-current flows. This stripping works on the basis of mass transfer because the solute is being diffused from one liquid phase to the vapor phase. This process involving the material and energy balance because in order to solute A to be slowly diffused to solvent C, which is in vapor phase, the driving force, which is heat, must be applied. The schematic diagram of the stripping process by using dissolver is presented here. The raw liquid that consists of A and B is being separated by using the vapor solvent of C. The solute in the liquid phase A is being absorbed from liquid phase of mixture A and B to the vapor phase C. In order to faster or to make it easy, the heat, which is the driving force, will be applied in order to create the ability for component A, which is the solute, to be easily absorbed or diffused to the vapor component C. And this involves the gas-liquid interface that A must be across. For example, in industrial application to remove the harmful contaminant from the waste stream, where the waste stream consists or liquid. Based on this schematic diagram, the vapor solvent that enriched with component A or solute A will be removed from the dissolver to form the product vapor of A and C, whilst the component of A that has less affinity to vapor solvent B is still remain in the B to form the product liquid of A and B. The example of bubble cap tray that could be found inside a stripping column in industry is shown here. The stripping process is mainly conducted in tray towers or plate column and the pack column. There is less often application of stripping process by using the spray tower, bubble column, and centrifugal contactors. Now, humidifier. Humidifier is a device that increases humidity, which is moisture in a single room or an entire building. Industrial humidifiers are used when a specific humidity level must be maintained to avoid static electricity buildup. The static problems are prevalent in industries such as packaging, printing, paper, plastic, textiles, electronics, automotive manufacturing, and pharmaceuticals. Friction can produce static buildup and sparks when the humidity is below 45% relative humidity. When the relative humidity is in between 45% and 55%, the static builds up at reduced level, while when the relative humidity is above 55%, RH ensures that the static will never build up. Secondly, preserve the material properties. Humidifiers are required in cold storage room in order to preserve the freshness of food against the dryness caused by the hot temperatures. Thirdly, ensure a comfortable and healthy environment for workers or residents or visitors. The art museums use humidifiers to protect sensitive works of art, especially in exhibition galleries, where they combat the dryness caused by heating for the comfort of visitors during the winter. The humidifier involving material balance. The schematic diagram of the humidifier is presented here. As a terminology, the feed gas A is not being saturated. The liquid B is evaporated in the process unit, and the vapor will occupy the feed gas that entering to the humidifier. Then the vapor exit A and B products may or may not be saturated and produce the wet gas. For example, humidification of air by using H2O. There are various types of humidifiers. For example, steam humidifier or vaporizer and impeller humidifier are called as a natural humidifier. These are usually non-commercial devices that can be assembled at a little or no cost. Then, ultrasonic humidifier. Ultrasonic humidifier use a ceramic diaphragm vibrating at an ultrasonic frequency to create water droplets that silently exit the humidifier in the form of cool fog. The others are natural humidifiers with non-electric and hydropneumatic control, spray mist humidifiers that use also the water droplets, and evaporative humidifier. A device that has an opposite function as humidifier is called as dehumidifier. Dehumidifier is a household appliance which reduces the level of humidity in the air. The purpose of the dehumidifier is to provide the health and the comfort zone to the people, as well as to eliminate the musty odor in the environment. The large dehumidifier used in the commercial buildings in order to control the humidity level. Dehumidifiers extract water from the moist of air or gas. This collected water, called as the condensate, is often discarded from the moist of air or gas. This dehumidifier involves only material balance since there is no heat is being considered throughout the process. The schematic diagram of the dehumidifier is shown here. As a terminology, the feed stream contains of condensable components, which is A, and the non-condensable components, which is B. The condensate is a liquid with the condensable component, which is A. From the moist gas, only A is a component that will be condensed throughout the process and to form the condensate liquid, while B is a non-condensable component that removed from the dehumidifier as an exit gas. The dry gas exit stream, which is the exit gas B, contains of a saturated with condensable component B at the temperature and the pressure of the process. As an application from this dehumidifier is the dehumidification of air. There are various types of the dehumidifier used in the commercial and the industrial purposes. There are portable dehumidifier and portable absorption dehumidifier are being used commercially. The difference is portable absorption dehumidifier use the function of adsorbent inside, whilst the industrial partially disassembled portable dehumidifier is being utilized in industries. Now we move to the adsorption process. What is adsorption process? Adsorption process is a process where a component of a gas or liquid stream is removed and absorbed by a solid adsorbent. The picture that shows the adsorption process is shown here. Adsorption process is composed of two main components. The first one called as the adsorbent and the second one is called as the adsorbate. Adsorbent is a material that represented by the white strip at the bottom, whilst the adsorbate composed of either atom, ions, or molecules that has high affinity to be trapped on the surface of adsorbent. Based on this picture, adsorption can be called or can be defined as the addition of atoms, ions, or molecules from a gas, liquid, or dissolved solid to a surface of solid. A schematic diagram of the adsorption process is shown here. The adsorbent that contains of the material is located inside the column. The adsorption process creates a film of the adsorbate on the surface of the adsorbent. Adsorption is also called as a surface phenomenon and consequence of surface energy because the absorption is only occurred on the surface of the material or adsorbent. Absorption can be classified into two types. The first one is a physical absorption, or to be short as physisorption. And the second one is called as chemical absorption, or to be short as chemisorption. Physical absorption or physisorption, where is the molecules are attracted by the van der Waals forces, and the chemisorption, where the molecules between the adsorbents and the adsorbents are attracted by the covalent bonding. The exact nature of the bonding depends on the species involved. As an application, adsorption process are widely being applied for the heterogeneous catalyst, activated charcoal, gas adsorption, water treatment, and purification. What is the difference between adsorption process and absorption process? Adsorption process is a process where the gas, liquid, or dissolved solid, which is adsorbate, is dissolved on the solid surface of the adsorbent, whilst the absorption process is a phenomenon where the fluid, which is the adsorbate, is dissolved by permeating a liquid or the solid, which is the adsorbent. Therefore, the adsorption is called as a surface-based phenomenon, whilst the absorption process is the bulk phenomenon because it covers the entire structure of the liquid or solid. The adsorption process is an exothermic process which releases the energy and preferred or favored at low temperature. And the absorption process is the process where it requires the energy. That's why it is endothermic process and it doesn't affect by the temperature. There are various types of the adsorbent that commercially been applied for adsorption process such as activated carbon, alumina, zeolite, and molecular sieve. However, currently, most of the researchers and scientists convert the thinking and the knowledge to the utilization of the agricultural waste such as coffee ground, coconut shell, bamboo, and palm kernel to be converted to the useful product, which is the adsorbent that has a lower cost as compared to the commercial adsorbent or the existing adsorbent in industries. Now is crystallization. Crystallization is the process by which a solid form where the atoms or molecules are highly organized into a structure known as a crystal. Some of the ways by which crystals form are precipitating from a solution, freezing, or more rarely deposition directly from a gas. Attributes of the resulting crystals depend largely on the factors such as temperature, air pressure, and in the case of liquid crystal, which is the time of the fluid evaporation. Crystallization occurs in two major steps. The first is nucleation step. Nucleation step is the appearance of a crystalline phase from either a supercooled liquid or a supersaturated solvent. The second step is known as a crystal growth, which is the increase in the size of particles and leads to the crystal states. An important feature of this step is that loose particles form layers at the crystal face and launch themselves into open inconsistency such as pores, cracks, etc. Crystallization is also a chemical solid liquid separation technique in which the mass transfer of a solute from the liquid solution to a pure solid crystalline phase occurs. In chemical engineering, crystallization occurs in a crystallizer. Crystallization is therefore related to the precipitation, although the result is not amorphous or disordered by a crystal. The application of the crystallization process is a snowflake during the winter. Next is filtration process. Filtration is a process of separating solids from fluid, which is liquid or gases, by adding a medium which is filtered through which only the fluid can pass. In other words, filtration is a physical, biological, or chemical operation that separates solid matter and fluid from a mixture with a filter medium that has a complex structure through which only the fluid can pass. Solid particles that cannot pass through the filter medium are described as oversized, and the fluid that passes through is called the filtrate. The oversized particles may form a filter cake on top of the filter and may also block the filter lattice, preventing the fluid phase from crossing the filter, known as blinding. The size of the largest particle that can successfully pass through the filter is called as the effective pore size of the filter. The separation of solid and fluid is imperfect. Solids will be contaminated with some fluid, and filtrate will contain the fine particles that, depending on the pore size, filter thickness, and the biological activity. As an application, there are various types of the filtration application in the chemical engineering, such as biofilter, which is the combination of the filter and the biological digestion device. Chemistry for the separation of material of different chemical composition, such as the coffee filter to keep the coffee separate from the grounds, the bag filters to extract the precious metals in mining. Then, the furnace used filtration in order to prevent the furnace element from fouling with particulates. In the laboratory, a Buchner funnel is often used with a filter paper serving as the porous barrier. The air filters are commonly used to remove the airborne particulate matter in the building ventilation system, combustion engine, and industrial processes. Then, we learn about the screening process. Screening is a process of taking granulated ore material and separating it into multiple grades by particle size. The schematic diagram of the screening process is shown here. The solid mixture that contains of the multiple grades by particle size is entering to the screening process. After the screening process is done, the fine particles that are able to passing through the screen can be found at the bottom part after the screening process is completed, while the coarse particle size of solid can be found on top of the screening drum. The applications of the screening can be determined from the mineral processing, agricultural, food, and recycling. For example, separation of coarse sugar and the fine sugar and the sieving of powder. This is the example or the model of screening process. Now we learn about the membrane separation technology. Membrane technology covers all engineering approaches for the transport of substances between two fractions with the help of permeable membrane. In general, mechanical separation processes for separating gaseous or liquid streams use membrane technology. Membrane separation is a process where a mixture is separated using a semi-permeable membrane, which allows only one component to move through faster than others, that resulting in differential transport. The material is act as a semi-permeable barrier. As a membrane mechanism, this membrane will control the rate of the movement of various molecules between either two liquid phases, two gas phases, or liquid and the gas phase. Membrane separation processes operate without heating and therefore use less energy than conventional thermal separation processes such as distillation, sublimation, or crystallization. The separation process is purely physical, and both fractions, which are permeate and retentate, can be used. What are the meanings of the permeate and retentate? Permeate is the components that less mobile species, whilst the retentate is the component that moves through the membrane faster. The diagram or the schematic diagram of the retentate and the permeate components are shown here. The cold separation using membrane technology is widely used in the food technology, biotechnology, and pharmaceutical industries. Furthermore, using membranes enables separation to take place that would be impossible using thermal separation methods. Membrane separation technology can be classified into four major operations that are pressure-driven operation, concentration-driven operation, operations in an electric potential gradient, and operations in a temperature gradient. The pressure-driven operations such as microfiltration membrane, ultrafiltration membrane, nanofiltration membrane, and the reverse osmosis membrane. Based on this type of four classification, it used the pressure as a driving force. Then the second class is a concentration-driven operation such as dialysis, vaporization, forward osmosis, artificial lung, and the gas separation. The third operation is based on the operations in an electric potential gradient such as electrodialysis, membrane electrolysis such as chloroalkali process, electrodeionization, and electrofiltration and fuel cells. The only type of membrane that operates based on a temperature gradient is called as a membrane distillation. Now we come to the last important unit operation, which is heat exchanger. Heat exchanger is a system used to transfer heat between two or more fluids. The heat exchangers are used in both cooling and heating processes. The fluids may be separated by a solid wall in order to prevent mixing, or they may be in direct contact. The application of heat exchangers are widely used in space heating, refrigeration, air conditioning, power station, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and the sewage treatment. For example, the most important or the most commonly used heat exchanger in industry is known as the shell tube heat exchanger. Shell and tube heat exchanger consists of a series of tubes which contains fluid that must be either heated or cooled. A second fluid runs over the tubes that are being heated or cooled so that it can either provide the heat or absorb the heat required. A set of tubes is called as the tube bundle and can be made up of several types of tubes, which are plain, longitudinally, and fine. Shell and tube heat exchangers are typically used for high pressure application, which the pressures has a greater than 30 bar and the temperatures is greater than 260 degrees Celsius. This is because the shell and tube heat exchangers are robust due to their shape. Several thermal design features must be considered when designing the tubes in the shell and tube heat exchanger. The second type of the heat exchanger is known as the hot water in the bathroom. This is for the commercial or the household application of the heat exchanger. And finally, the last example is called as the plate heat exchanger. The plate heat exchanger is another type of heat exchanger that commonly used in industry. These exchangers are composed of many thin, slightly separated plates that have very large surface areas and small fluid flow passage for heat transfer. Advances in gasket and brazing technology have made the plate type heat exchanger increasingly practical in industry. You can see here the several types of the heat exchanger. This is the tubular heat exchanger, and this is the commonly used of heat exchanger in industry, which is the shell and tube heat exchanger. The heat exchanger is also being used for cooling process. The heat exchanger of cooler is a device used to transfer heat between a solid object and the fluid, or between two or more fluids from process fluid to the cooling fluid. The process fluid being cooled. There are several examples of the using of heat exchanger for cooling process that are cooling of drinking fluid, refrigeration system, air conditioning system, car radiator, and the condenser. One of the widest use of heat exchangers is for air conditioning of buildings and vehicles. This class of heat exchangers is commonly called as the air coils or just coils due to their often serpentine internal tubing. Liquid to air or air to liquid HVAC coils are typically of modified cross-flow arrangement. In vehicles, heat coils are often called as a heater cores. On the liquid side of this heat exchanger, the common fluids are water, a water glycol solution, steam, or a refrigerant. For heating coils, the hot water and steam are the most common, and this heated fluid is supplied by boilers. For example, for cooling coils, chill water and refrigerant are most commonly used. The chill water is supplied from a chiller that is potentially located very far away, but refrigerant must come from a nearby condensing unit. When a refrigerant is used, the cooling coil is the evaporator in the vapor compression refrigeration cycle. That's all. Thank you.